There we go.
Well, welcome to the July 11th, 2023 session of Tangerine SDR and Ham-Sci technical session. My name is Dave, KV0S, and this week I followed up with Dan on trying to get a hold of Scotty, and we'll see if I don't know if he'll show up. He was talking about showing up more often, but we're just trying to get figured out what's going on with those the RF boards and getting those figured out. So that's been it for me. I've had some family issues that I've been taking care of, so that takes a little of my time, and I've been still dabbling in KA9Q radio quite a bit. It works nice when I get it working, but when I try something new, I tend to break it. So, but the nice thing is I can get the old configuration back. So anyway, that's it for me. Next on the list, let me get the list up where I can see it. Okay, next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Things are going along fine here. Just trying to keep up with everything. It's very busy. Bob McGuire came to Scranton and visited this week. We worked on putting up an antenna for the Ionosonde project, so we made some progress there. Still working out some of the licensing issues for that. The other thing I did this week was I got the Frontiers paper resubmitted, so I haven't heard back yet, but that is back in their court. It's about 59 pages, so it's pretty substantial, and now I am on the hook to write a paper on traveling ionospheric disturbances using SuperDarn data and RBN WhisperNet data pretty much as fast as I possibly can. Next week, I'm going to Switzerland for an MSTID meeting. So just trying to keep all of these balls in the air is a challenge, but yes, we're doing it. So back to Net.
Well, congratulations, and I'm glad you're not bored with nothing to do.
No, definitely not bored.
Next on the list is Michael, AAK. Go ahead, Michael.
Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list is Bob, N4HY. Go ahead, Bob.
Okay, so as Nathaniel said, I went to Scranton this past week, and I had quite a good time with the student that Nathaniel and I are working with, building the Ionosonde. I picked up my red pitaya to see what we can figure out about what's wrong with the source and sink for GNU radio or with the red pitaya, and I will work with Pavel Demin to try to figure that out. And I spent time with Nathaniel and Majid, and I don't know whether people here know or not, but Phil Karn and I have been best friends since early 1980s, and he drove me pretty much crazy the last 3 years while he was writing the software-defined radio code for the Raspberry Pi. So I am ecstatic to hear that Tangerine is going to go the embedded Linux PC role, at least initially, so that many more people can participate in writing the software-defined radio code. And so I am now very interested in helping. So count on me to be a regular. And I will work with Phil to help and figure out how to get his stuff running. And of course, you know, I love software-defined radio since I've been doing it forever.
Well, very good, Bob. Glad to hear that you're excited. Okay, next on the list, we have another Bob, N5BRG. Go ahead, Bob.
Okay, hello, everybody. Yeah, I did get the magnetometer in the ground and got it started collecting data, and so I'm trying to sort out some of the issues there. But glad to see that finally working. So now I'm going to turn my attention to the grape receivers, get one, maybe two of those up as well. And I'd like to hear something about this antenna y'all worked on, what kind of an antenna it was later on in the conversation, possibly. So back to you, Dave.
Okay. Next on the list is David in one HAC. Go ahead, David.
Oh, great. Throw me in the pool.
Well,
And I use the term advisedly here. We're floating away over here in New England. We got a lot of roads and bridges missing. Worst damage since Irene some years ago. Yeah, but yeah, I spent the day working on a repeater, listening to the rain on the roof, trying to get one up. We've got a big bike rally coming up this weekend. Hopefully, if the route stays clear. We have repeater coverage, and I was working on a multiple service repeater system. I'm trying to finally found a dead preamp that was killing our receive. Got that done, but boy, it was, yeah, we've got a lot of water going around, flowing right now. Almost done, but there's more predicted. And yeah, I've been very busy this week with various projects. Have not received an RX 888, but have it on order, should be here momentarily, and I'm looking forward to seeing what all we can do with those, and also some antenna preamps to try out. Come up with various options for what people can use, and more shall be revealed. Back to Net.
very good. Next on the list is Dave Whitten, KD0 EAG. Sorry. Go ahead, Dave.
I keep putting that in there and it goes away. Yes, well, it's been doing this and that, trying to help a few people with the magnetometers, and try to track down some documentation on the final ones that were actually manufactured, but I'm not sure whether I've found it or not. And but other than that, I think we've got a couple folks pretty close to where they want to be. I've been continuing to research the Cypress-based radio designs and look at all the different ones. I got a Booyah SDR today, and I have a couple of the RX 888s and some of those. Looks like most of the action's in the drivers. What else? Well, that's most of it for me, frankly, right now. And I've been working on getting an editable schematic in KiCad for us to use. Getting pretty close to that. Sent out a PDF of it to a bunch of folks, but there are a lot of the finer points of RF design that are beyond my ken, and I will want to ask folks about. So that's it for me.
Very good. And next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
Yeah, greeting to everybody's out there. For the past 2-3 weeks here, I've been really busy with Society of Automotive Engineers cybersecurity stuff. So haven't had a lot of chance to do anything amateur radio related, except this past weekend I got to play a little bit of FT8. Very annoyed because I heard Saudi Arabia came in on a one and done. I just, on FT8 20 meters, heard it call CQ. That was it. gone, no more. So a little bit on the frustrating side there. Would have been nice to work Saudi station. Ditto Lebanon. I heard them, one and done. So anyway, just a lot of automotive cybersecurity, been really wrapped up in that, and now hopefully I can get back to doing some of this stuff. Nathaniel, and everything regarding that requirements document that I wrote for the solar eclipse QSO party, even though it's still a work in progress, there's absolutely nothing stopping the team from going to work and starting to use a lot of it. It's not necessary to wait for the final version. It's going to be a living document. So there's nothing stopping them from taking off. Other than that, Nathaniel, have a good trip, a safe trip, and we'll catch everybody else later on down the log. 7-3, back to net control.
Okay. Next on the list is Jonathan K. Rizzo, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. I've been pretty busy this week, but I have some very good news. I mentioned last week that I was working with a student from Georgia Tech under Morris Cohen, and he developed a method that uses amplitude data from VLF transmitters to look for acoustic waves along the path. And he actually published this method at CDAR when he submitted the poster. So I ended up sending him data from 2 VLF transmitters on the day before of and after the Tonga eruption. I was sampling the amplitude. What it does, it will take an average of the bandwidth and log that value. So I gave him data on NAA and NAU, 40.8 or 24 kilohertz and 40.8. And lo and behold, there were actually some results, and I am absolutely ecstatic. I will share one of them with you. This is Whoops. So what he does is he analyzes sections of the data, time slices of the data. And then he does an FFT. And what he calls outliers, which is indicated by this dip in the blue trace here. This indicates an acoustic wave. And so he found 2 acoustic waves, this one and another one, that occurred after the Tonga eruption. He did not find any acoustic waves on the day before or after, but he found it on the day of and after the Tonga eruption. And there's also a possibility that this may not be due to the Tonga eruption, but there's a strong likelihood that this is. So he found this on NAU. So NAU is in Puerto Rico. So the path from there to Pennsylvania is actually quite long. The path from NAA in Coulter, Maine to Pennsylvania is much shorter. So he didn't find anything on NAA, but which I kind of expected. But he did find this on NAU, and one of the really cool things about this is now this VLF system it's actually producing real science and real results, which means that it's actually quite significant. And what I'm thrilled about is that I built this system. it started as an idea, and I put everything together. I got everything working. I did the engineering. I was very meticulous to make something that was useful, reliable, and perform well. And it's just absolutely thrilling that something that you build and create is actually producing real science data. So now the next steps are is the sample rate. So these were sampled at once every 5 seconds. But his data that he normally works with is sampled once every second. The problem is that in the summer, the data is very noisy, and that's because of lightning, especially daytime lightning. So, so this will work in the winter, but not in the summer. There's some filtering that will have to be done to the data. I also could use the spheric blanker as well, and see how that fares. But yeah, this is actually very exciting, and I've also been looking at how I'm going to do the loop antennas, the orthogonal loops for the H-field receiver, and it seems like the best way to do it is with right isosceles triangles, which is how Morris does it, and also the way that the author of VLFRX tools would have done it had he not had a restriction in height where he lived. And I'm also working on more on the H-field receiver and the 3-channel system. That's all I have. Back to Nanette.
Well, very good. Interesting stuff. Congratulations. Next on the list is Rob. A1 AI 6VN. Go ahead, Rob.
Good evening, Dave and the group. I'm, as you probably heard, I've been really focused working with Phil Karn's K9Q radio software to integrate it with my Whisper Daemon software. I think hours away from alpha testing it. But everything, life gets in the way. But it's in operation and has been for a month or more at KFS. So we have a very good sense of its potential, and it's meeting all of our needs for Whisper reception, as well as it's now the platform for the WebSDR implementation out at KFS. So instead of having 8 RSP1s attached to a server, you can have one 16-bit RX888 and get better quality, lower bandwidth than 1/8 the hardware. So it's very, I mean, all the evidence suggests right now that basing a SDR on Phil software is the right way to go. And I'll soon document be documenting its performance with Whisper reports from KFS. So that's my major focus right now, and I am encouraged by the work that Dave is doing with Franco on the receiver. We need an alternative to the RX888. It's just not a good long-term solution. I saw in I think a private message from Phil that he was also looking into using a overload, introducing an overload signal, a PPS signal, and detecting it to do phase synchronization among multiple RX888s. So it may be that Phil will come up with a software solution for that functional requirement of the Tangerine, or are we calling it Clementine? What, I don't remember what the current name of this is, but anyway, I'm mostly here to validate what's going on and because with the driver and the hardware, and so far everything looks good. So back to Net.
Okay. Well, and next on the list is Tom, N5EG. Go ahead, Tom.
Okay, I've got to find the mouse there. Not much work on the receiver this week. I've been testing out the clock module. I've got a survey grade choke ring antenna installed during the week up on the peak of the roof, and been looking at the performance of the clock module, and its timing uncertainty looks fairly good on it if you can use position as an indicator of timing uncertainty. I got the Tapper GUS, which is the GPS unfiltered splitter, and I'm able to run the HP 3801 GPS with the double oven crystal oscillator and compare it against the clock module. So those tests are ongoing, and the antenna seems to be working well. The Tapper Gus module is working well. You had to be quick to get all the parts on the order. John put out the memo, and within a few minutes, some of the pieces were gone. So glad to have that. And that's it for the week.
Well, very good. Yes, I got one of those Gus's too, and it's a nice little piece of kit. So next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everyone. Sorry for being late, but it's been extremely busy here. Been working on a grape that Red sent over and got the major problem solved with it. So it'll be going back to him here in a couple of days, as soon as I test it a little bit more. And my grape still cranks out data. Thanks, Dave.
Very good. So I think I've gotten everybody on the list, and I haven't, nobody said anything. So we're going to be open for general discussion. By the way, Rob and Bob, I've been working on some collecting documentation pieces in one spot on a GitHub on my GitHub site for KA9Q radio. I talked to Phil about this at Dayton, and I'm moving forward, but I expect at some time we'll get more people participating in that.
There, yeah. Do you include Clint KA70EI's documents? Because
Yes, yes,
okay.
I have Clint, I have Franco's stuff, I have many sources, and I've collected some obscure sources of Phil's.
Well, good. Well, that's I think that the key thing that we're missing on, as I understand it, in this project right now, is a schematic for the 888.
Yeah.
And I saw another SDR being explored, but I don't know. I looked inside my 888. I got another one here. I'm actually I'm exploring one of the things I'm exploring once I get Whisper Demon working is I want to see if I got an orange Pi. You know, the Raspberry Pi, I have many of the Pi 4s, but I'm running, most of my sites are now requiring more CPU than you can get on a out of a Pi 4. And one of my sites, the site down in Brazil, is running an orange Pi, and so that gave me a thought that I'd get one. And this looks promising. I'm hoping that maybe that there is enough power in this thing to run 9Q. We have the 888 plugged into this thing and run 20 or more. Well, once you get up to there, if you can do 200 channels on a Pi 4, this thing has maybe 4 times the CPU power of a Pi 4, and it costs less than one of the costs now, at least online. So anyway, this might be a promising platform for those who want to just get going and start working at the higher levels of their software. So I'm posting my progress on this thing probably to my forum, the whisperdemon.org, groups.org, Oops, I'm sorry, touching my keyboard. On my progress on that, or maybe, hopefully I'll have something running by next week, so I can report back. But I think, this is $100. This is, 165 or so. And if it does all Whisper, all JT9, everything, all the WWV bands, everything, seems possible that you could do it all in these two packages. So
Right.
one of my thoughts was that once I get Whisper decoding going, I'd put in a grape decoding mode for Whisper Daemon, and you could specify a grape channel, listen to the WWV tone and upload the data. I can't really find a definition of that or a place even to run grape software. There's I gather a special modified enhanced version of FLDigi that's used with it, and it outputs CSV files, and then those are massaged and uploaded. Is that the basic grape process?
Yeah, that's the basic process for the Grape One. We're trying to migrate away from that to just capturing about up to up to 4 kilohertz of spectrum around WWV/WWVH, so that you could potentially decode the entire voice signal as well. And then on, depending on the amount of bandwidth available in storage, there'd be levels below that. So the next level down would be, say, just capture 1500 hertz of bandwidth, which would let you get both the 1 kilohertz and the 1200 hertz tone, and then capture, then the next level down would be capturing about 700 hertz of bandwidth, so you could capture the 500 and 600 hertz tone, and then all the way down to, say 10 hertz around the carrier, which will give you really nice measurements of the Doppler shift, but it won't really make it easy to disambiguate. Are you hearing WWV or WWVH?
Mm-hmm. Well, Phil is talking about, and in fact, we were thinking about the Eclipse, and Phil was talking about, can we, at least on it'd be a little more performant platform, just capture the full 0 to 30 megahertz IQ stream and record it in real time. And then you guys could go back at any time in the future and poke at any frequency, at any bandwidth, whatever tools you have. And so I'm hoping that if these this obviously that's not going to happen on a little device like this,
right?
But it doesn't. If you look at a 30 mega sample, 60 mega sample, 16-bit per sample, you're looking at 120 megabytes per second. And you can write that. You can stream that amount of data to a USB 3.0 hard disk. So a 4 terabyte hard disk could have several hours, I think maybe more than several hours, of full 0 to 30 megahertz IQ sample stream. And my thought is that if, that if Phil gets it working, we might try to, at the Whisper Daemon sites along the Eclipse path, we might put have receivers that are capable of doing, making those recordings. And, later on uploading them for archival purposes and for the, later research.
I agree.
So that's on the kind of, it's probably the improbable wish list, though. I think that but it's pretty clear we're going to have RX 888s, and that means you can have IQ recordings of 60 kilohertz wide IQ recordings around all of the WDV stations. That part seems really straightforward. It feels now, as I start to work with his software, it's it just sits there. I never really restart his engine, his Radio D, the internal engine. I don't restart it. I just attach to it and tell it what I want, and it gives me a audio stream. It'll give me an IQ stream, and it's incredibly flexible. So I think it's well worth our time to understand the capabilities of his platform, because I think it will provide a tremendous range of features for a wide range of user needs.
Yeah.
I'm focusing, of course, on Whisper, and
Right.
and you guys heard, of course, maybe that you hadn't heard well, you have, of course, that Ryan Tolboom is making progress on extracting the spreading data from Whisper signals,
Right.
which would, I think, completely change our frequency measurement world. I mean, we now could measure the stability of each Whisper transmitter out there, and cull out of that pool the transmitters that are truly stable.
Mm-hmm.
And then at stable receive sites, we would be able to get Doppler shift data from all of those, from all of the whitelist of beacon sites. And given that there's almost 3,000 beacon sites, hopefully, we don't know, hopefully some small percentage of them will be stable enough to be useful for Doppler shift measurements.
Right.
What is an Orange Pi?
An Orange Pi, it's a single board computer that is based upon a rock chip, which is a member of the ARM family. I think I don't know who makes it, but this is a Chinese-made board. It's apparently been around for quite some time. It has you can install a standard Ubuntu 2202 LTS image on it, so it's a completely friendly application environment and server environment. It has,
Well,
many of the.
How would I find one? Just type in Orange Pi into.
Yeah, just search for Orange Pi
Okay,
on
got it. Thank you.
Amazon, and you have $100, and you'll get one the next day.
Okay, thank you.
And you'll need and the images use the Ubuntu 2202 image. That's and which is they have on their site. So
Okay,
you need a micro SD with it. That's all, and a
I
power
would
supply.
like to mention Phil Karn just showed up. So, Phil, do you have any comments?
I browbeat him.
Hi, Phil.
Hi, guys. I just heard about this meeting through Bob. Thought I'd listen.
Well, so we've been talking about you. Your ears been burning?
Well, Bob said it worked.
So I was telling Phil I got this rock chip, and once I finished my Whisper Daemon in integration with your software, I was going to hook these two up and see what kind of performance I can get on this rock chip part. If it's quite a bit more powerful than a Pi 4. My just general impression is that it's approaches that of a little i5. So.
Oh, okay.
So it might be a very interesting platform, a combination, system combination, but we'll see.
You following my progress on the RX888?
Following your what on it?
Progress.
Oh yes,
I got
absolutely.
running at full speed now.
No, I did. You said something about you'd gotten rid of the one copy of that was involved with multicasting the raw feed. And
yeah, I
and
put
what was
the device handler right into K9Q into the radio D for at least the RX888, and now
Yeah.
it runs full speed.
So and what percentage you're running on what platform?
i5.
Which i5?
Let's see. Let me find out. Guess I have to look at proxy CPU information, huh?
Yeah.
I 8260, 1.6 gigahertz.
Well, that's that's a fairly powerful i5 then.
Is it? Okay.
Well, it's 8250. You said it's the 8th generation.
It's 8260.
Yeah.
8 cores, 1.6 gigahertz.
Yeah.
And
I'm seeing these i5s for $200. I don't see why people don't just go ahead and graduate to an i5 and quit fooling with the Pis for something like this.
Exactly.
Well, yeah, I mean, if you for the high end stuff, sure, but I mean, a Pi is just fine for a lot of stuff.
If you're gonna do all of HF with these whispers, you might as well.
Yeah, if you want all of HF right now, I can't do that on a Pi, but I could try.
I don't think the Pi is just unobtainium, and
It's
I-
improving right now. It's rapidly
Yes.
improving.
Actually, it's getting much better.
Yeah.
well, I'm not using them anymore. They don't have enough CPU power for.
Well,
for,
I mean, you
work.
know, use whatever you get. I mean, I
Yeah,
don't care.
yeah.
I'm agnostic as
Yeah,
long
I
as
know.
it's,
Yeah.
So I have a question too on the whisper mode, using whisper during the eclipse. And you're trying to also monitor with a grape, for instance. What about transmit? Are you expecting to be transmitting and receiving while monitoring these frequencies?
Well, for the Whisper Demon group for the Eclipse event, there's 5 or 6 of us, oh no, maybe 8 of us who are going to be along the path of the annularity. And we will, and at most, we're all trying to put up, well, many of us are going to have transmitters that are all bands, 80 through 10, simultaneous all bands. So they're going to be transmitting during every cycle on all the bands. And located nearby, maybe a few hundred yards away, we're going to try to have Kiwi SDR receivers listening on all bands. So, you know, the sites we've tried this at, I just did one yesterday, even maybe 100-yard separation from the transmitter and the receiver, the 5-watt output transmitter did not overload the Kiwis, and the Kiwis were not desensitized by the by the transmitter. So there should be a wealth of data from these sites. That's our hope.
So you're going to listen to all the whisper frequencies and to the WWV frequencies.
Yeah, there's no reason to. The WWVs are easy. They don't really require. You don't do any decoding with them. All you do is record the audio. I mean, you know, that's easy. The whispers. Decoding the Whisper D decoder as it just chews up CPU cycles forever. So decoding Whisper in real time is what limits is the limitation. The limitation is CPU power. If you're just recording signals, well, Bob, Phil knows you can record a couple of hundred demodulated channels at once off of a Pi 4. So it's it's not the demodulation, it's the decoding that is the limit in the CPU limitation in real time.
Well, couldn't you post decode, just record during the eclipse and then process your data later to see what you were copying?
Yeah. Although it's yes, of course you could, and that's why Phil, I mentioned the possibility since you're making such great progress of recording the whole IQ stream to a hard disk, so that we had the 0 to 30 megahertz spectrum recorded on the hard disk.
I commented on that last night. It's a little too fast for a spinning disk. It might work with a RAID 0 or with an NVMe SSD. It's less than a terabyte an hour, so you can still do it.
Yeah, well, a RAID 1 or a RAID 2 rather, parallel disks. I mean, they if you have enough USB 3 throughput, I think is your.
Well, a RAID 1 will not improve write throughput. It may improve. It may, RAID 0 may do that.
Yeah, I forget the different RAID things. You have to remind me.
RAID is interleaving striping. One is mirroring.
Yeah, okay. Well, you don't want mirroring. That doesn't help. It's 0 where you can stripe across multiple disks.
Right. Actually, for reliability, I think an SSD is the best. I mean, you can get 4 terabyte NVMe SSDs now, reasonably cheap.
Yeah, well, I think that this may have an NVMe. I'm not familiar with those, but in any case, I've never had occasion to use one. But I mean, something like this, then, if you could write the whole stream to NVMe in 4 terabytes, you'd have a couple of hours of the whole spectrum.
Yeah, it's a little tricky because it's faster than 8 gigabit. So we need 10 gigabit Ethernet if I'm going to do anything with a network in real time.
Right, yeah, I wouldn't want to put it across the network though. Don't you?
Well, I'm thinking redundant writers.
Oh well, you're okay, well, that's a different, yeah.
Well, I mean,
Well,
look, I mean, you can't rerun these things, right? You want to make sure.
You're right. Well, well, then you're gonna have to do something other than one of these little boards and.
Well, yeah, I mean, how many do you need though? Is the question.
No, probably. Well, if I were to equip all of the Whisper Demon sites along, it would be 6 or 8 of them along the path of annularity or totality next year.
Yeah.
And
Well, this will be a good dry run for next year, won't it?
yes, that's part of it. But in some requests, it's Nathaniel and the scientists need to tell us that, we need customers who will actually use this. I mean, otherwise we're just fooling around for our own interest.
Well, Nathaniel, tell me, would you like to have a recording of all of HF during one of these eclipses, or is just a bunch of defined channels? And you tell me.
I think it depends. I think having all of HF would be fantastic, but that's also going to be an absolutely tremendous large amount of data to comb through. And so, the question is, who's going to be the person to actually do that? But
you have modern computers, right?
We do, but it's just a matter of, so I mean, if we're able to record it and we're able to store it and then someone can look at it, I think that's great. One thing I had thought about was it'd be really neat to do all of these recordings and then put a general call out to the community saying, hey, ham radio operators, we have all of these terabytes of data available from the eclipse. What can you do with them? And then, make that available for whoever wants to, analyze it and then see what people come up with. I think in terms of what I'm trying to do with the grapes and the solar eclipse QSO party and things like that, we have the advantage of doing the slice receivers for WWV with the grapes is that we have a consistent data product that we can distribute across the entire continent, and we have it's a very manageable amount of data, and lots of people should be able to field one of these stations with fairly low cost, and we're able to provide a lot of these stations ourselves. And then it's also a fairly tractable amount of data to actually process after. So that's why we've been, pushing towards the grape. But if the facilities are available, and if, the whole bands could be recorded, I mean, of course, that's the superset of everything. If you have that, you have everything.
Yeah, I mean, Rob, I don't know if you've noticed, but at KFS, I'm already demodulating all of the WWV streams.
Oh, I know you. I know who you are, and what I was suggesting is that it would be good. There needs, that I would like to, if I had time, take those streams and then, like I do with Whisper, decode them and upload them to the WhisperNet servers to extract the grape information from those WWV and CHO streams that are being decoded already. There's just right now you're not doing anything with it. They're sitting there.
That's right. It's just spewing out as multicast streams.
Yeah. So we need, it's a software task that somebody would need to do. If someone's interested in doing software development work, all of those streams are sitting there at KFS, and will be at every one of the Whisper Demon sites very soon.
Okay, probably then, if you want to cut the data down, what you want to do is do an IQ recording of each slice of WWE. Right now, I'm receiving each one twice. I've got an AM detector and I got a offset carrier detector.
And I mean, that's what we're planning on doing with the grapes, is just an IQ slice of the WWV channels. So that is the plan for the grapes and for what we're trying to adapt for the for these RX-888s and the Tangerine. So and because I think that is manageable. As I said, I would love it if you could get a full IQ of the entire HF band from around the world, stations around the world, and have that archived somewhere. And I know I spoke with KM3T a bit at Dayton, and he did say that it was possible that he might be able to use his servers and the contest receiving network to do this sort of thing. And then he could host the data for some period of time. I don't know if their stations are GPS disciplined or what the quality of those receivers are, but there is an offer to basically do wideband recording from that contesting network.
Okay, the whole issue of calibration is one we're going to have to work at. My thinking is you can only do it with an end-to-end thing, like putting a 1 PPS into the antenna,
Right.
and counting samples from there.
I
with that-
agree.
Yeah, this, in fact, Phil, that was, I mentioned to the group earlier that you, I think you mentioned in one of your emails that you were looking into utilizing the 1 PPS as a stimulus to the input of the ADC, and using that to do synchronization between multiple ADCs. Did I express that accurately?
Yeah, that's right. That's right.
Okay.
I just got to make sure I don't blow up my A to D converter.
Yeah.
I'm
Well,
curious. Good.
Go ahead.
I was curious from Majid if we had an update from from Kung and Rob Troy at Scranton, if they've made any progress with getting the digital RF decoding of the slices or the digital RF recording of the slices.
Nathaniel, no, we are not there yet.
Okay.
We're waiting from Stan to send us some information.
Okay.
As whatever he did, that he could record that digital RF, and I'm not sure if he did record all of those in the same directory. Did he solve that yet, or? But we're waiting from him.
Okay. And what is the progress on, say, GPS disciplining one of these RX 888s? Because I know there was some talk about, modifying them or, but
they have a UFL connector on the printed circuit board. You can buy a little 50-cent UFL male to SMA female and drill a hole in the back and of the RX 888, and you've got your external GPS input. I guess there's a jumper on the board, on the PC board, to select the external input.
Okay, then that's taking what, a 10 megahertz signal, or
takes 27.
You actually don't want 10 megahertz. I got 10 megahertz floating all around my shack, and
right.
You know what that means.
Well,
Yeah.
Try that.
I did try that on 27, and when it was receiving WWV just fine, and when I put in the 27 signal, I got static. So there's something, I'm not sure quite how, if I did it wrong or what, but
you might talk to, I know that Glenn N6GN has implemented that.
Okay.
And he says it works perfectly. I mean,
I think both
is perfect. He says
it's
which
not
is
exactly
I've never
27.
I think both Dave Witten and I are interested in that.
It's not exactly 27, Dave.
What is it?
Oh, I forget. It's some odd number.
Okay.
Like something like 27.288. I don't remember.
Yeah.
But it's the standard crystal for the standard clock for the Cypress chip, or
I'm sorry. Okay.
Are we just overriding instead of the crystal that's on board? It's the 27 megahertz crystal is the one that's used to time the Cypress chip out of the box, and we can experiment with that for sure.
Yes.
Oh yeah, and actually, Glenn was telling me this morning that the oscillator is good enough, and of course there's no transmitter here, so it's very constant temperature environment, and he thinks that it's not as good as a GPS DO, but he thinks that even up through 10 meters, you might be able to get tens of millihertz stability and accuracy out of the RX88. So
does anybody have a schematic for the Mark II yet?
And
No.
we no. We've been searching for, yeah, that's,
Dave Witten has one for a
No.
earlier version.
Yeah, I have the earlier version, but it's very different. The market is very different.
yeah.
Is it that
That's really
different?
interesting.
I had been under the impression that it wasn't very different.
It is. I mean, the attenuator and gain amplifiers are different, and I'd like to see the low pass filter because I want to know what kind of aliasing response this thing's going to have.
Okay.
Yeah.
Because one way to
Yeah.
knock down the data requirement is to lower the sample rate, but if you do that, then you have to be careful about aliasing.
Yeah, I was gonna talk to Clint, KA70EI about maybe a enhancement of his high pass shelving filter with adding 30 megahertz anti-aliasing to it, because like every other SDR, this thing is is going to be overloaded. Well, less so than a Kiwi and others, but it will be overloaded by AM and even the shortwave broadcast stuff. So you really need to have some specialized filters in front of, I think, in front of the 888. As they do, such a filter is in front of the 888 at KFS, Phil. You're not looking at the raw.
Right.
You have there's a 15 dB gain qubit LNA, which is preceded by one of Clint's high pass shelving filters, and that's what protects the Kiwis and the ARCs 888 from being overloaded by shortwave. The 41 meter and 25 meter band broadcasters.
The
What
main
is the-
problem
what
really
is
is medium
What is the
frequency.
sample rate on the what is the sample rate on the Linear Technologies ADC and the 888?
I'm looking.
Well, you can.
It's an LTC 2217.
Yeah, but I don't remember. I don't remember what
Yeah.
the
Is that
number
the one in the, is that the one in the 888? I thought they
Yeah.
were using, I thought they were using LTC 2809 or 2209.
Well, I think that changed in the Mark II, but I think
see, okay.
2217. I have the data sheet for it. It can sample up to 130 megahertz, and that's where I'm running it now. But it's a waste. The input is low pass filtered.
And it's what's the low pass? The low pass filter on it? Of course,
Well, I mean, logically, if it samples 100 and
you think it's 60, but
130, then it would be at 65, right?
yeah. But
so hang on now. If it's sampling at 130, and I mean there are processing gain mathematical games you can play to improve the dynamic range, etc., on the receiver, but typically you need a hefty processor to pull that off. So,
Well, I'm doing it now, Bob. I mean, I got this running on an i5. I'm handling the full sample rate. Now, what I can do is I can digitally low pass filter it to capture just 30 megahertz. I mean, if the antenna doesn't see anything above that, then what's the point?
okay, so if you downsample and filter to 30 megahertz, it's a net gain. So you want to make sure you make sure you increase the accumulator size to more than 16 bits. I bet you're using floating point anyway, so you got
That's
plenty
right.
of-
That's right. Yeah. But you
But
want to
you're doing all
record. You
that.
want to record all that, though. I'm saying is the disk space is the limiting factor here. If I'm
Oh yeah, we want to cut down on the actual stuff streamed to the disk drive as much as possible.
Right.
Can't you generate a signal, Phil, and sweep it and see where you drop off?
I can do that.
Right.
Yeah.
Well, you can't. You'd have to do it on yours. The KFS one has a lot of filters in front of it already. So.
Yeah, which is good. But where are those filters, Rob? I mean, where do they cut off?
Well, there's no anti-aliasing filter ahead. The Kiwi has its own, and we're depending upon the anti-aliasing filter and
the shelving filters you were telling me about. Where does that cut off?
Well, the shelving filter has a well, I can go show you, but basically it suppresses below 10 megahertz. You get about 15 dB of suppression below 15.
The high end.
The high end, I think Yeah, let me go look. I don't know that he even put up, maybe, I think he may have, well, I better be careful. Let me go to look at Clint's blog and it'll tell me, but I don't remember.
Okay, all
Okay,
right. I
so
mean,
just so before I forget about it, because I'm going to drop off in a second. I think it was Bob or somebody that asked about the antenna. So the antenna we put up at Nathaniel's for just our initial demonstration purposes on the ionophone were fan dipoles. That is not what is ultimately going to be the antenna. So we're going to have an active antenna to cover the receive, and we're going to do some experimental antennas for the transmit, so that we can, because we don't want to transmit in the ham bands. We're getting a license to be able to transmit outside the ham bands. So there's still work to be done there. But initially transmitted in ham bands with chirp, and then once we have the software running, et cetera, then go work on the rest of the antenna system, and do get as much done as we can before October.
what frequencies, Bob?
Oh, just 80 and 40 meters right now is all we're going to be doing.
Okay,
for
so this is
initial
a chirped waveform of some kind.
Yeah,
Okay,
it's FMCW. It's just a chirped waveform.
right. What I'm trying to get at for what I want to do is, if we are going to record a raw SDR like the RX888, I mean, what kind of data rates do I need to work with? That's what I'm trying to get at. If you tell me the antenna bandwidths and the frequency ranges you want, then I can tell you, how fast my data rate is going to be.
Yeah. Yep,
You tell
absolutely.
me. You guys tell me. I mean, Nathaniel, you tell me, how high do you want to go?
With the HF?
Yeah. If we do a raw recording, how high do you want to go? 30 megahertz?
Yeah, 30
50?
megaherts.
Okay.
Yeah,
Nothing
I mean,
above that.
50 is good too. It,
Huh.
well,
I know scientists want it all. I know they
Yes.
yeah, I mean, I'll be happy with 30 megahertz, but I know some people want 50 megahertz. So I mean,
It sounds like Bob. This sounds like a conversation I had with Tom Clark from Dayton.
Yeah,
many
of
years
course.
ago.
So look, I'm a little bit more restrictive. So for NVIS, I don't need anything above 10 megahertz.
right. So I mean, if you're asking me how much wideband data do I want, the answer is all of it. And how much can you afford to give me? If
All
you
right. Well, the
okay,
problem is,
if you can't right, if you can't afford to give me all of that, yeah,
Right.
30 megahertz is great. 10
as soon
megahertz
as
is
the
awesome.
real-time data rate exceeds a gigabit, things get
Yeah.
harder, right?
Right.
For obvious
So-
reasons. Right.
So yeah, so I mean, going up to 30 megahertz is very reasonable, and going up to 20 megahertz is also very reasonable. So it's this balance of like technical ability versus what we can do. So I mean, it really comes because there's interesting science that can be done with all of it. So if you give me 30 or 50 megahertz worth of data,
Okay.
I'll say, oh right, we're gonna go look at what we can find with sporadic
Well,
E or at
30,
these higher
30
frequencies.
megahertz. Okay, 30 megahertz. Real samples. Nyquist rate would be, the sample rate would be 60, assuming
Right.
that I have a really good digital filter. It doesn't
Yeah.
require a lot of excess.
Yeah.
With 16 bits, that's just about a gigabit.
Yeah. But
real time.
Can't do that with a digital
but in the
filter.
last eclipse, I think
Actually,
the
I
best
can.
data I got was up to the 20 meter band. So that was 14 or 15 megahertz. So like if you say, all right, we can reasonably technically do and reasonably afford to do 15 or 20 megahertz of bandwidth, that's fantastic.
Okay, I can get you close to 30.
Yeah, go for it.
Well,
Okay.
but can you do it in a way that can be duplicated by a bunch of other people with their equipment?
Well, that's just it. That's why I'm trying to keep the data rate below a gigabit, so things can go.
Yeah, I
along
think
with
there
that.
are plateaus that you're
And-
gonna
and
wanna
that's-
look at here, like he started
Yeah.
off earlier talking about 8 kilohertz around each of the WWB stations.
Right.
Well, I
You
can give you
said you
that
have that
too. I
working.
mean, you
Okay.
tell
Yeah.
me what you want.
And maybe that gets a lot more people out there collecting data and.
Well, that's the whole
broader.
point of having that grape standard. It's a very focused thing. It doesn't have a lot of technical requirements. It's it's affordable, it's technically achievable. So yeah, and we can get useful science out of that. So
Okay.
Could
so
we
the
back
question-
up a moment? How do you get 30 megahertz with a 60 megahertz sampling with a digital filter?
What
How
do
do you
mean?
get the aliases out?
Well, okay, let's say I start with a RX 888 and I run the hardware at full speed, which is 130 megahertz. Okay, that means its Nyquist rate is going to be 60, or it's
Okay,
cut
so
off
you
to
are
85.
oversampling. Okay.
Well,
Yeah,
yeah,
you
and then
have
I
to.
use my own filter to knock it down to 30, very close to 30, and I can decimate at the same time and get a stream with very little overhead, because I can build you a very sharp filter. The
Okay,
same filter
well,
I'm
you
already
weren't, it wasn't
using.
clear you were oversampling.
Oh yeah, that's how I would do it.
Okay,
Nathaniel, I need to go, so I'm going to be shipping you the 5-watt amplifier tomorrow.
That sounds great. Thank you, Bob. And I
Yep,
think I better say 73 as well.
Yep.
Okay.
All right. See you
did we-
guys. Thanks for
Thank
coming
you.
on, Phil.
Yeah.
did we
sure.
get an update on the Clementine?
In what way?
Well, how far along is that? I also wanted to know if we had made any progress with the receive card connector problem.
So I said at the beginning, before I started the recording, I was able to talk to Nona today. But and she said Scotty would call me back, but I haven't heard back.
Okay.
And then I
Yeah,
also
I came on late too, so I missed it.
I texted Scotty also. And then Dave Larson said that he reached out to Dan and for XWE, I think. And Dan had gotten in touch with Scotty, but no real progress has been made.
Okay. Is Scotty aware of it?
Yeah,
we
I
don't
mean,
know?
I texted him. I sent a
Okay.
text saying that we're having continuity problems with the receiver board. So assuming he reads his
Right.
text messages, he's aware of it.
Because as
And
far as I'm concerned, it's a simple assembly problem
So
and should be sent back to the assemblers.
right. So I guess the trick, I guess the thing to do is find out who assembled it and send it back there. But I don't know if there's if that doesn't work, if there's another place that can handle it.
Yep. Well, first thing is to get a hold of Scotty and the assemblers.
Right.
If they're worth their salt, they'll fix it.
Okay.
Okay. Thank you.
All right. Thank you very much, everybody.
Well, before we go, Nathaniel, what was that modification on the RX 888? Was it the GPS DO or GNSS DO?
It's both. So GPS is the United States version or brand of global navigation satellite systems, and GNSS is a more generic term that will refer to any global navigation satellite system, regardless of what country is running it.
I see.
And people
Anybody
have
in this group done this before?
Oh, yes.
evidently Glenn has done it successfully. This person, Glenn, who works with Rob, has done this before.
What do you mean by done this before? Specifically with an RX 888 or
Yes.
just in general?
Yes, with RX 888.
Well, it's just you generate the frequency and you put it in. We do that with a lot of different receivers.
Okay.
But the part where you're drilling, I think Robinette has experience with this, where he said he drilled a hole, put a connector on there, and then attached it to the UFL connector on the board.
The person to talk to is Glenn N6GN, and he's the first person to actually. I physically haven't made that modification. I think that Gwen Griffiths also has just gotten a 888, and he's going to make the same mod. If I could get through my software tests, I'd work on this one, but I got so much other stuff to do. I don't have time to make the mod.
I'll just say I definitely will be doing it.
Yeah, I want to have a GPS disciplined 888 out at KFS though, because that I have a GPS disciplined Kiwi 14 channel Kiwi there, and the ultimate test for me for my application is to compare the spot counts between those two systems, because I know the Kiwi. I mean, we worked through all of its bugs over the last 6 years and understand it and have resolved all of the subtle issues. So it to me is a reference for certainly for whisper decoding. a source of samples for whisper decoding. And so my goal is to compare that Kiwi, which is posting as KSF right now and has been for years, to compare those posts, those spots against the ones that we get from the KFS/Q. Well, I may actually make it KFS/Q with the oh no, I can do /Q. And if any of you look at the top spotters list or something, you should in the next week or two see KFS/Q pop up on the top spotters list alongside of KFS, and hopefully maybe even a little bit above it. I mean, I don't know. We'll see.
I just sent you Glenn Elmore's contact information, Majid.
Okay, thank you.
Yes, okay, yeah, Majid, I don't have, the modification is on the, I don't know. It's, I don't know who maybe now
I did open this RX-888. I opened it,
Yeah.
and then I know the connection plays.
Yeah.
And we do have that KV GPS discipline from previous project from Nathaniel, who's our students that's working with
Gerard's
this?
project.
Gerard. Yeah, thank you.
Yeah.
Yeah, we could borrow that, and then
Right.
I could tap that in that connection. I think that should be simple enough.
Right. We may need to order some more of those.
Yeah,
because,
you can buy the little cables are like 50 cents a piece from Amazon. You'll have them in 2 days. So it's
but more GPS DOs.
You'd want to get the level.
Yeah, I think it's the same one that's used on the Ham It Up used with RTL SDRs. There's a little connector on there that I think is the same thing.
Yeah.
Anyway, I'll find out because I have some of those connectors.
Okay.
But
Well,
I think we'll want to order separate GPS DOs so that Gerard has one for his project, and yeah. Although for what Gerard's doing right now, there is a GPS DO built into the Edis, so he is good at the moment.
Okay.
that is the subject I was going to suggest as a consideration for the Clementine. Is that GPS DO seems to me to be almost essential for any scientific use of SDRs.
Right.
And it's so at this point, I've been talking with John Ackerman, and he's Glenn has shared with John his Glenn's low-cost GPS DO reference board design, and this is the one that I have. Here's an example of it, but this one. And the goal of this design is to achieve the stability needed sufficient for all 30 megahertz and below requirements, but optimized for low cost. And John is this uses a $30 Wi-Fi capable SCM or module, and John thinks that he can use a 75-cent Arduino part on the board, and that would almost half the hardware cost of this design. And the goal, and it's already down. This is down to $40, so it might be able to get the hardware costs of the whole GPS DO down to like in the order of $20 on the board.
Can I get some information on that kind of a design to include with
the person that it would be helpful for you to talk to John and stimulate John, because Glenn is waiting for John, and I think John is, and so it would help stimulate John to turn his attention to this reference board project. I have some developers in my Whisper Daemon group who might be able to help on the Arduino programming, because it'd be Glenn's software for this thing it's all open source, but his software is web oriented and based upon using a Wi-Fi interface.
Remember, we have our own reference board design too.
Yes,
for
you
Tangerine.
Do. Yes,
but
I
yeah,
think
John's the one to have test that out and see if it
that's
passes muster.
Glenn has been waiting for John for weeks to do it. So if this group were to approach John and say, John, look at Glenn's design. This is not as high performance. It's not. The goal is not to get millihertz stability at 2 gigahertz. The goal is to get millihertz stability and good phase noise performance up to 30 megahertz. And by reducing the functional requirements to those that are relevant to our shortwave.
Personally, I'm skeptical you're going to get that with $20.
I think you should. Then you should look at it. You should. Glenn is designed the HP spectrum analyzers back in the 80s, so he really does know what he's doing with microwave design. He's but he was looking for John to make his measurements. Anyone who's familiar with this is welcome to. Glenn would be happy to have them examine it.
What he probably should do is not just give it to John, but post it to the Time Nuts.
Well,
people will be very interested.
Well, Glenn has so many projects that he's very wary of getting involved in larger groups. So you notice he isn't present in this group, and
well,
so
there you go.
I kind of act as his proxy in some respects in these discussions. So,
but the way you get it looked at is to bring it to the group.
Well,
can other people get that board that you're holding up?
Yeah, I mean I need to talk to Glenn about, he wants knowledgeable people to work with it, but yeah, I'll talk to him and say that this group is interested, several people are interested in trying this design out. The problem with it is that it's not really the right design, and it's awkward to work with. You got to set up your own Wi-Fi router with an SSID and password right. It's all embedded into his software. So it's not a trivial device to play with. You have to be Wi-Fi and aware. So that's why he's been one of the reasons he hasn't.
Doesn't sound like a problem.
Yeah.
Why does it need Wi-Fi?
Well, it was because he inherited it from other, this code and this little board from other projects. So that was easy for him to do it this way. But in terms of productization, that wasn't his interest. And I'm trying to help. And he offered it to John as a way to for the thought as Tapper could offer it as a low cost, alternative to the high-end board that John has designed for the.
It also has to compete against the Bodnar.
Well, it's not a Bogner. It doesn't. It's using the Bogner uses a microwave capable chip. This is the lower part.
I don't know what you're meaning, microwave capable.
There's a 53. It's a SI part that's used for the.
But it has nothing to do with being microwave. It doesn't create microwaves.
It's no, but the internal clock on the 5351 is a 900, 800, 900 megahertz, whereas the part in the Bogner runs its internal clock at 4.8 gigahertz.
The stability of the clock is what's critical, I think.
Yeah, so the device.
Well, it really comes down to the reference oscillator.
Yes, it's the internal reference oscillator frequency is much higher in the Bogner, and as a result, it achieves much better stability and accuracy.
That's not really where it comes from, but okay.
Well, anyway, it's there's a bunch of hidden things. Glenn and a number of our group have been exploring the 5351. Is that anyway?
There are 5351s in the RX888 design, are there not?
Yes, they use. Yeah, it's used in that design. It's used in many parts. These.
And in part, that's where the 27 megahertz reference frequency comes from, because that those part likes that.
Yeah, and but the if you're not putting in the RT280, the tuner chip for VHF and UHF, then you have extra clock outputs from the existing SI 5351 that Are they useful in any way? I don't know.
Well, Glenn brings them out on this thing. He brings all three of them out. So,
Okay, yeah.
so the
Well,
but
it's going to have to be looked at by the group. You can't just focus on one person.
Well, as I say, I think you guys, the best place to start is to talk with John rather than because
I'll try to
Glenn-
get in touch with him.
All right. Well,
okay. And
I mean, I've had John test out stuff that I'm wondering about, and he's been pretty quick about it. So
He's
Well,
pretty
matter of
busy
getting him
right now,
interested.
though. He's a
Yeah.
pretty busy guy.
well, right. Anyway, I think that we're all driven by
But the
what
other thing that, we have to be very careful with these references because it's very easy to get just a little bit off on frequency or have it wander. We don't want it. I mean, over time, it may be accurate, but if it's wandering, you're going to see it in the data.
there's been a lot of there's been that's why we're looking for other other people to look at to validate
There are
this,
Chinese GPS DOs that are out there that are off by 10 to the minus 10th.
yeah.
But it's a
Well,
very
true,
repeatable,
but it'd be
measurable
nice
10 to
to
the
take a
minus
look at
10th.
your
It's like,
board. It'd be
why
nice
did
to
you
look at it.
do it so close and not right?
Yeah. Well, my mind was bent by looking at the 5351 and how how the fractional n computations if you have multiple output frequencies. There's an amazing amount of math complexity involved in utilizing those parts in various applications. So you can't, for example, the Bogner, you cannot create a 25 megahertz and output, and at the same time output from the second output 66.66. That there's none of the register combinations generate that pair of output frequencies.
Yeah.
And those are that's so it's a whole area of expertise unto itself. But
yeah, and there are those of us who do that.
What's that? I'm sorry.
And there are those of us who do that.
And that's bless you all. It's a way. Okay, we need accurate oscillators and stable and low phase noise and all that. So it's but in any case, Glenn's object in the purpose of this is not to be better than a Bogner or to duplicate a Bogner or any other design. It was specifically targeted for a 0 to 30 megahertz SDR that had the requisite accuracy, stability, and low phase noise.
But we have to be able to look at it to know if it's going to meet the specs that we require.
Well, if you're John Ackerman has them, so I encourage you all to contact him, and because I can't. This is Glenn's part; it's not mine. So it's Glenn is looking for John, has respects him and has worked with him for a long time, and he's so I think it would be great if this group could encourage John to help on this project. So that's anyway. That's the reference oscillator possibility, and with a Bogner at $175, having something, it's just overkill for what we're doing at even up on 10 meters. I mean, it's just
maybe yes, maybe no. We don't know until we test it.
Yeah. Well, it's so
will he share the design?
Yeah, I think he may even have the design on his open source hardware page.
Okay, I'll take a look.
Yeah, it's code and everything is maybe there yet. I don't know if he put it up. Glenn is happy to share. He wants to do everything open source hardware and software.
Okay.
What he doesn't want to do is get deep into into supporting end customers. That's anyway, that's I was gonna let's see, it's 6. Let me see if he's put something up there on it. And hardware pages.
Is this Glenn? Is that N7GN?
N6GN.
N6G Gulf November?
Golf November. Yeah,
Thank you.
here's his page on it. Here, I can give you his page right now in the
Great.
chat with you. You can look at there you are.
Not seeing it.
There's
Oh.
the schematic is there. I don't think he has any. I don't think he has
Not-
any of his measurements.
We haven't seen anything.
The
Nope,
did you see my link?
no.
Oh, I went to Majid. I'm sorry, everyone. Okay, try again.
Great. Oh, excellent. Okay. Take a look at it. Oh, I
Yeah.
see. Okay, he's using the U blocks. How do you get that for $20? But yeah, it'll be good to look at. Thanks.
I think he's see, there's the firmware upload. He has various firmwares that you can upload. So
Is
his,
it
his single, you can see his price, what he got for pricing on his quantity 5 orders from JLPCB. But down at the bottom.
Is there some kind of standard for reference frequencies other than 10 megahertz?
There are all manner of, but 27 is very common, comes out of the TV
Yeah.
industry.
Yeah, the tuner, I think, in
But it's
the
not 27.0, it's something else.
Yeah,
What was that?
It's not 27.0.
It is 27.0. I don't know why
Oh.
someone's saying it isn't.
Oh,
I thought it was.
Yeah, at least if it's the standard TV reference crystal,
I think
it's
the-
27.
yeah, the RTL-SDR ran its clock at 27.
Actually,
Exactly.
the RTL SDR is at 28.8.
Is it? Okay, I thought, well, I
Why, I don't know, but it's at 28.8.
I struggled with that and gave up.
well, at least I don't care about Spurs at 27.
Yeah.
Yeah. No, we wondered why 28.8 and where it is it in the software? Can we change it? We never found it. We just generated 28.8 for it.
Yeah.
Well,
And there's a
Phil
problem.
is, Phil has uncovered my problem with the RTL was I couldn't tune it accurately, hertz accurately tune it.
Yeah,
up in the-
it's coarse
And
tuning.
I've worked that out. It's not coarse
Yeah.
tuning, it's just deterministic random tuning.
Yeah, but yeah,
Okay.
Phil has fixed it. He figured
Yeah.
out how to tune the darn things.
Yeah, I
And,
Okay,
dug
well-
into the synthesizer and figured out, what it's really doing.
Well, that's good to know. Yeah, we just
Yeah.
kind of put up with it.
And in KNIQ radio, I handle it. I don't care if it's actually on frequency as long as I know what it actually is.
Yeah, that's what we do.
Correct for it. Yeah.
Yeah. So Phil, if I were to plug in, if I run your software on a Pi or something and put in an RTL SDR, I could get it to tune accurately to hertz accuracy up on the VHF range.
Well, depending on the oscillator. isn't it?
Yeah, given I feed it with a Bogner.
Yeah.
Yeah.
RTL SDR, FunCube dongle, and AirSpy. I think I've done it for all of them. Because they all
Okay.
use pretty much the same tuner that,
Yeah.
what do you call it? Tuner, the 820.
Yeah. Yeah, I invested a month or more trying to get the tune the RTL, and then I realized I had to dig into the driver and figure out how the synthesizers worked. And at that point, I had other more important things.
Well, you can extract from my code if you still need it.
I wouldn't touch it. I'll use your code. I use your stuff,
Fine.
and I'll let you take care of it. Okay, I appreciate that. So
Yeah.
So anyway, that's one thing. The other thing that's going on, Glenn is working on an active balanced high impedance amplifier design, which many of us are using at the Whisper Demon sites. And we've been using it. Glenn uses it with the loop on the ground installations where he can't put up an elevated antenna on top of a mountain. And we were working with a Pierre up at VY0 ERC today, and with he has one of Glenn's antennas, and so that might be a design of interest as well if there's for antenna as an antenna possibility. Mostly we use it for low frequency stuff. Well, he has a hybrid input. Low frequencies are a 2 meter whip active dipole, high impedance input, and then for the medium and high frequencies, he uses the loop on the ground because it survives the winters in the Rockies, and it works remarkably well, actually. Very his site in Colorado very closely matches Clint's TCI 530 in Utah, which is 100 foot and $100,000, $200,000, 100-foot tall Omni antenna, and Glenn just about matches it with 2 meters in his LNA. From they're 600 kilometers difference, so they're never exactly the same. But anyway, that's another area. But I think the reference design is the most critical thing right now. Is that we need. I would hope that we'd add that right into the board in this in this Tangerine design, so that because the Bogners end up dominating becoming a dominant cost item in many places. I mean, they cost as much as the RX 888. So
I just posted a link on somebody who took apart an RX 888 Mark II.
yes, I do.
Thank you.
Yeah, make sure it's the Mark. I don't know. Is there Mark ones or the early ones for sale even?
I don't know. I was wrong
Okay.
about the A to D converter. They did change. The Mark II has a 2208.
Right.
Mhm.
Yeah, there've been a lot of 2208s apparently kind of flooding the market in China by some accounts. The reference design I've worked on, I put a 2208 in it, but because I have one, but in a test board, it's a 2208-14 instead of a 16. I may go ahead and get the equivalent 16 board just to have it.
Does that mean it's not good to 16 bits? It's only 14 bits.
The one I have was, for some reason, I bought the one that was 14-bit. Yeah, and so but they are seemingly identical except for the use of 2 additional.
Is it just lower accuracy? Is it a lower quality part? In other words, the effective number of bits is lower and still getting 16?
I don't know. I'm sure I bought it because I had seen Phil Harmon's demo. I was at Friedrichshafen a few years ago when Phil and some of the other folks demonstrated running the HPSDR code on a NVIDIA, an early NVIDIA developed nano type board, and he had just wire wrapped this stupid A to D onto a particular Altera board that had one channel of PCIe, and plugged it into that NVIDIA TK1 or whatever it was, and he was able to do 6 or 7 receivers in this thing, but it was just a wire wrap job, and he was just showing it off. It's on some of the old Friedrichshafen things, and I wanted to do the same thing. So but Altera quit putting any CERTAS in the low end chips. And so there was nothing I could work with after that did any better than that.
I mean, if you
And-
wire wrap it, I think, you know, the noise level is going to be pretty high. You're not going to get anywhere close to 16 bits.
Well, all I have, all my, yeah, well, this was, and so I bought a 14. But I think someone had told me that there was really no reason to pursue
Exactly.
the extra 2-bit bits.
Exactly.
But I have also read a lot, at least in the PCIe and the conversions. It's that a lot of this is a lot less dicey than most people assume. I don't know. You all have more experience with that sort of thing than I ever will. So anyway, it worked for Phil.
Okay.
And so I think I was going to duplicate what he was doing, but got distracted.
Okay. We about done here. My wife wants me to some.
Well, thanks for joining, Phil. I'm looking at
Yeah,
your
thanks.
I'm looking at you running your this little i3 running your software out of KFS is about most of the time it seems to be about 70% idle, and it's decoding all kinds of stuff. I don't know if I can. So yeah, I'm running top on it right now. And,
Yeah.
it's
Probably, even with the low utilization, you probably want to move the decoders to a different machine.
oh well, I
Just
I
for
can see you. I can
real-time,
see that. Yeah,
yeah.
I can see if. Yeah, you're not running your FFTs and such in user and kernel space, so they'd get preempted. Although I
I am
run all,
using the real-time calls, but I'm not sure you're running a real-time kernel that supports them.
probably not, and we're not. We don't. This is the generic kernel. This is the regular server. So
Yeah,
I would. Yeah, I run everything at nice 20, so because all the whisper processing can be done.
But still, there can
non-real-
be latencies in doing a task dispatch, which is
Yeah.
why,
Okay. Yeah.
you know,
Yeah. The switch out there is a managed switch, so it'll handle IGMP snooping
it
and all
does.
that.
It is okay.
Yeah. Yeah. So it's an ubiquity smart switch. It's a
Good.
very nice nice switch, managed switch. So okay. Yeah. I'll move I'll have to, I guess I may need to talk to you, Phil, because if I move off, I need to know how I reference these. Can I use the same multicast names if I move to another machine?
Well,
So
yeah.
that-
Well, no, you don't want to generate more than one stream with the same name, but you can listen to the same stream on multiple computers. Is the whole
Well,
idea.
Yeah, well, one of the things that I see is the way I'm using your software is that I run one instance of the wave recorder for each band, and the way the streams are currently configured, that means I throw away most of the SSRC frames that come in.
Well, yeah. I mean, that's
so-
okay. I mean,
Well, it's okay. I mean, each instance will be throwing away 95% of the RTP frames that come in. Is that?
well, yeah, but you got a fast network, right?
Yeah. I mean, I mean, it's only going to transmit it once. It's really just memory copying inside of Linux. It's not
Right.
network
I
traffic.
mean, I looked at your network. I looked at this machine last night, and
Yeah.
this what the network interface was doing. I think it was generating about a solid 12 megabits.
Yeah,
which
there's
is-
not much there. It's I
No.
think, yeah, if I well, we turned off the whisper decoding, so I don't think that your decoder isn't running. So when your decoder is running, the total bandwidth was about 30 megabits, I think. But with the whisper off and nothing asking for whisper, that stream is not present. So yeah, you don't have much. Okay. Well, so another machine would recognize the same. I mean, I don't know how who resolves these DNS names that you use.
Oh, that's how multicast DNS works.
Well, okay.
I mean, it sends out a broadcast saying who's got this address, and then I respond.
Okay. Okay,
Yeah, I'm
well,
putting
then
out about 11.8 megabits right now off that
that's,
machine.
that's nothing. It's all gigabit,
Right,
non-blocking.
exactly,
switch.
exactly.
Okay, good. Okay, well then I go forward. I didn't get to work on my interfacing to you at all today, so it's a.
Okay, no
And
problem.
then I'm going to be, I have a surgery tomorrow, minor surgery. So
Well, good luck
I
with
may,
that.
okay, but that means I may not be home until Wednesday. So, you know, what I hope to do this morning, well, now maybe I'll get it done by Friday. So
Yeah,
anyway, it's so close. I know it'll work perfectly, and it's real fun to work with your code and look at your C code and program in C once again for the first time in 30 years. So
well, I have this habit, you know, of saying, looking at people doing hardware work and saying, wait a minute, I can do this in software.
yeah,
I do.
yeah, it's well, okay. We've dragged down. I don't know if there's any other topics that interest.
Okay, if nobody else needs me, I gotta go. My wife wants me.
I gotta go. I
Yeah.
got work to do around the house. So anyway, nice to join you all. I plan to be around on Thursday, hopefully, for the solar eclipse stuff, and hopefully, but maybe if there's one to do out of this, maybe we can all get look into Glenn's reference design and talk John into making measurements and see if there's a path to.
Rob, send me the Zoom links for these meetings so I can put them on my calendar.
Okay, this one, yeah, I always have trouble with this one because I have to get it off the calendar, and each time I do it, so I
They're
will.
all of the links are on
Okay.
hamsci.org. If you click the Get Involved tab at the top.
Okay.
So just put the link in the chat. It says Hamsci Telecons. There's TangerineSDR Telecon, Grape Low Cost Personal Space Weather Station Telecon, and Solar Eclipse QSO Party Telecon. And so there's direct Zoom links right on the website.
Got him. I see the calendar. Wonderful.
Great.
All right. See you guys.
Good.
Great. So I'll be on Thursday, but then I will not be on next week.
Yeah.
Okay.
Okay.
All right. So long.
Thank you.
Okay. See you all again.
73.
73.
Okay. 73. Okay.
Good night, everyone.
Good night.